squared. We're doing an additional example right now. Yeah, so z squared is equal to -4. We drew it out. Yeah, so it's going to be r squared, and then you're doing Euler's formula, E, right? We'll call it 2I theta. The 2 came from, okay, so in general, z is equal to RE I theta. If I take both of these sides and square them, I'm left with z squared on the left-hand side. And if I square the right-hand side, I have to square both of these bases. The base of r gets squared and it's r squared. If I square e to the I theta, that's squared, which means you're really multiplying the 2. So it's going to be e to the 2I theta. So far, so good? It's really just a rule of exponents. Okay, so I have the left-hand side. I need to also convert the right-hand side. Again, I need a modulus and I need an argument. Modulus is pretty easy. What's the distance from -4 to 0? The distance is what, Emily? How far did I move to get from the origin to our complex number? 4. So that means I write 4 here. That's our modulus. And then I'll go ahead and keep using Euler's formula because it means I have less to write. E to the I theta, but theta is a certain value. So it's going to be I times something. Theta is our argument. What is our angle? What is the angle to get from here all the way over here to our complex number? Caroline, 180. So this is going to be I times 180. The 2, well, this side's being squared. This side isn't being squared. It's just like a normal number. So theta is, you're just plugging in whatever theta is. 180 in this case. The thing about 180 is the same thing as 180 plus 360, which would be this way. Or 180 is the same thing as 180 minus 360, or plus 360 twice. The way that we do that is we say it's I 180, and I'll put parentheses here because I needs to be multiplied by all this, plus 360n. I didn't make the mistake like I did last time. Okay, we've done step 1. We've converted everything into polar form. We use Euler's formula, so it's a little bit easier to write out. But it contains 2 basic pieces of information. It is going to have an equation for our modulus, and we're also going to get an equation for our argument. So what should be our equation for our magnitude? I can't speak today. For our distance. Oh, you're thinking too far ahead. Let's just set up the equation first. Yeah. So what we're doing right now, everyone, is we're trying to match up pieces. This r squared matches with that 4. So we say r squared equals 4. We're matching up pieces. 2I theta matches up with I times 180 plus 360n. We're just matching those together. Those are where our 2 equations stem from. So this is going to say r squared, that matches the 4. That's a nice, easy equation to solve. And we also have this 2I theta should match up with I times 180 plus 360n. If those 2 are the same, then this equation is also the same. All right, let's start off nice and easy. R squared is equal to 4. How do I solve both sides? Solve for r. What is our new modulus? What do I do to both sides to undo a square? Go all the way back to algebra 1. Sorry, I'm going to get someone new. Jaden, you haven't talked yet. How do I undo a square? Square root. Yeah, if I square root both sides, then that undoes the square. So say square root of the left, square to the right, and then Jen, you get what? Yep. R is equal to, no, square root of 4. 2, there it is. All right, Jaden has our new modulus. We just need to figure out what our argument is. Yes, Beverly. Okay. Yes. Take both sides to the power of 1/2, which is the exact same thing as taking the square root. Yeah. So if you guys prefer, you can do it just like we had in the notes previously. I think this is what Ellery was about to say too, and Beverly just said it. You can take both sides to the power of 1/2. Both sides to the power of 1/2. And again, if you type this in your calculator, 4 to the power of 1/2, it will spit out a 2. Okay, we solved one of the equations. Let's solve the next one. Notice that I have an I and I on both sides. Let's divide by I. Shoink, shoink. The i's are gone. We divided both sides by I. Then what do? Don't need these parentheses anymore since the I is not being distributed into that quantity. How do I solve for theta? Oscar, how do I solve for theta? Divide by, not quite. Right now, theta is being multiplied by 2, so undo multiply by 2. Yeah, divide both sides by 2. Divide by 2. Divide everything here by 2, which really means divide each term by 2. So now we have our theta. Our theta is 180 divided by 2. You guys can all shout out. 180 divided by 2 is, well, one of us got it, 90. And 360n divided by 2 is, shout out, 180n. So there's only really 2 answers between 0 and 360 degrees. Let's just find both of them because they're really easy. So let's go ahead and make our table again. Our value of n that we get to choose, it just has to be a whole number. What spits out? So let's choose the easiest one, 0. I'll say between 0 and 360. And there should be only 2 answers. By the way, if your range is 0 to 360, like the entire circle, the number of answers that you'll have is that power right there. We're gonna have 2 answers. If I had z to the power of 6, I would have had 6 answers between 0 and 360 degrees. Though each solution is called a point of unity. So there are gonna be 2 points of unity. Well, I guess technically a point of unity is when this is set equal to 1, but it's basically the same thing. All right, n is equal to 0. That's the easiest one. What angle do I get out? Aurelio. When n is 0, plug in 0. Say again? 90, yeah. Let's choose the next highest one. When n is 1, I get what, Emily? So this n right here is a 1. 1 times 180 is, and then 180 plus 90. $270, yeah, and that makes sense, right? So 180 lives right here, add another 90-degree angle, shrink, comes down here and points straight down, 270. And notice that if you add another 180 degrees, you're really just flip-flopping between up and down, 90, 270, 90, 270. Okay, we basically have our answers, right? I just need to convert it back into rectangular form. Let's draw out where our answers are. So my answers, this was the point that I'm trying to get to. What do I start with? I start with either something that's down or something that's up. How far up and how far down? Jaden told us 2. I go 2 up. This modulus right here is 2. This modulus right here is also 2, which means our 2 answers are what and what? Ellery? Yep, so this point right here, 0 plus 2i, or just 2i. You can say it either way, right? And then this point down here, Leo, is what? This one up here was 0 plus 2i. This one is negative 2i. There it is. So we can box our answers. It's 2i or negative 2i. And this is the part where you might start growing and be like, really, Mr. Sindel? Check this out. We could have solved by just square rooting from the very beginning. Yeah, it does work. But this is a way to check your work, because I'm not going to give you something that easy on the test. I'm going to give you something harder, but it's a way to check your work. So check this out. So if I have z squared is equal to negative 4, if I square root both sides, square root, I'm left with z is equal to, whenever you square root, you have to do plus or minus, and the square root of anything negative, it pops out an I, and then you have 2. So plus or minus 2i. But you can solve it using the same process that we just showed you. You want to try another one kind of like this? Slightly harder? Just. Oh, this next one you can't do that. That's why I'm just turning up the dial and difficulty up a little bit. Up a little bit. I'm going to do the same type of problem.
Try one with the square root.
Sure. If we get to it today. By the way, while I'm erasing, how do you guys feel about learning outside on this tiny whiteboard that is half in the sun, half in the light? Okay. I guess the other side of that is, how do you feel if you were at home and you had to watch this lesson where it's not digitally and it looks kind of not so great on Zoom? Would it still be okay? You would much prefer the digital version? Okay. So, yeah. Well, no, like on days that it's like super, super smoky where you're not even allowed to come to school, I'm not going to come out here and do it. But I just feel like if there's like half the class is gone and you have to zoom in, then I'm not going to come out here for the other half of the class. I'll just do it inside. That's the type of question. Okay, so here is your new problem. Z to the power of 3 is equal to 1. There are 3 answers. Do you know why there's 3? Because to the power of 3. I can give you one of the answers right now. Are you guys ready for this? One of the answers is 1. Because 1 to the power of 3 is 1. You guys have to find the other 2, though. There's as many answers as there are to the power of. Unless I restrict the domain and say, hey, it's between here and here, then I'm usually looking for just one of them. I want you to find all of them. I did one of them for you. I did the hard one. Okay, so what are we going to do? Look at your notes. It's almost exactly the same process. Yeah, Beverly.
We're gonna do Z to like cube.
Z cubed, so R cubed?
R cube, yeah.
Yep.
Times E cube I theta.
There it is. Yep. So we have now converted the left-hand side into polar form, and this is polar form using Euler's formula. Perfect. The right-hand side, we need to convert that to polar form, which feels kind of weird, right? 1 can be thought of as all these complex numbers, and the answer is yeah, it can be. Again, if you break it down into its components, where does it live? Where does 1 live? And then how far do I go in that direction that you pointed to? That's all that's being conveyed in Euler's formula right here. What's the modulus?
I don't know, man.
What is the distance from 0 to 1?
Oh,
1.
1.
The modulus is 1. Now everyone point to it. I know that the distance is 1, but where? Where do I go? Where does 1 live on the complex coordinate plane? Come on, point to it, guys. It is right there. What is this angle? What is my armpit angle? I haven't moved. So my angle is 0. So I'm going to do 1 times e to the I, and then all of this is going to be in parentheses. It's going to be 0 plus 360 n. Yes.
So last time we did 180 plus 360.
Yes.
Is that because we were on this side?
Exactly. That was a negative number. Now I have a positive number. And sometimes you're going to have 45 degrees. Maybe I'll give you something that has like the square root of 2 in it. Again, baby steps. I'm only slightly increasing the dial. Okay, we have everything converted to polar. Now what? I'm going to come up with 2 equations. You need to tell me where they come from. Caroline, give me one of the equations. R cubed is equal to what? Equal to 1. Again, this first equation comes from just the first piece, r cubed and 1. These two match each other, so it's r cubed equals to 1. Let's get our next equation. We just set the powers equal to each other. Just read out the powers. Who's got this? Chewy, go for it. Just read off the powers. Oh, that's another problem. This is 3 to the I theta. 3I theta is equal to, close, there's an I in it also. So 360 Ni. All right, there's our 2 equations. Again, they always come from match up your modulus and modulus. Match up your power and power. There are your equations. The i's will always cancel out. So maybe a shortcut for the next time is just don't even list the i's, because I can divide both sides by I. Gone and gone. Okay, the math here is pretty straightforward. The cube root of 1 is what? Ellery. Yes, 1. So you cube rooted both sides, or you're doing to the power of 1/3? Okay. Power of 1/3. Power of 1/3. Punch it into your calculator. What's 1 to the power of 1/3? And the answer isn't actually 1/3. It's something else. What is it, Beverly? 1. Yep. How many times do I have to take? 1 times itself 1/3 times is 1. Because 1 times 1 times 1, no matter how many times you have it, is 1. It's a property of 1. The square root of 1 is 1. The cube root of 1 is 1. Any root of 1 is 1. This is saying the cube root of 1. We're almost done. We got like 30 seconds left. Let me rush through this problem. I'm going to divide both sides by 3. Theta is therefore equal to 120 n. Let's make my table of n's and thetas. 0, 1, and 2. I don't need to go to 3 because I already have 3 answers here. 1, 2, 3 answers. And I know there's 3 answers because it's to the power of 3 in my original problem. So when I plug in 0, I get 0. When I plug in 1, I get 120. When I plug in 2, I get 240. Those are our answers. We need to convert it back into rectangular form. Where do those live? Well, 0 lives right here, and a distance of 1 means the answer is 1, which I told you guys. 120 degrees comes up here and makes a 30, 60, 90 triangle. And 240 degrees comes down here and again makes a 30, 60, 90 triangle. What is the length? Well, the hypotenuse is 1. To move from the hypotenuse to the short leg, I divide by 2. So this length right here is 1/2. And to get from the short leg to the long leg, I multiply by √3. So this is 1/2 of √3, or √3/2. Notice that 1/2 is going left, so it's a negative 1/2. This square root of 3/2 is going up, so it's positive. This square root of 3/2 is going down, so it's negative. And here are all 3 answers. Your answers are z is equal to 1. That's one of the answers. The next answer is negative 1/2 plus I √3/2. And the third answer is negative 1/2 minus I √3/2. Box it, we're done. And I can stop this too.